Personal finance practice problem using Excel. Annuity due present value calculation. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. Information on the left-hand side, going to populate that into the blue area on the right-hand side, comparing and contrasting annuity calculations for a standard annuity, present value of a normal annuity, versus the present value of an annuity due, or in other words, an annuity where the payments happen at the beginning of the period as opposed to the end of the period. In other words, normally when we just think about an annuity by default, the payments we're assuming are happening at the end of the time period, and we can then choose to have the payments happen at the beginning, but of course that will affect the end result. The easiest way to start looking at that is to see the Excel functions, in my opinion, to see what those differences are. Then we'll kind of solidify what is actually happening in our mind by doing a running balance calculation, and we'll try to verify doing the future value calculation so we can kind of go back and forth from present and future value, which might give us a better understanding as well. Let's start off with the standard annuity calculation in Excel. So we've seen this in the past, so I'll do it fairly quickly. Negative present value, so that we can flip the sign, shift 9, and we're going to then say that this is going to be equal to the rate, the 5%, we're on the rate, and then comma, the number of periods is going to be 6, and then comma, the payment, because this is an annuity, we use the payment of the 1,000. Now, normally that's where we stop, and we just know that the default will then be a normal annuity typically, which will have the payment at the end, and we could say enter, we get the 5,076 about. But note that if I double click on this, you see that we still have these two kind of arguments down here below that we could go to. Now, normally these two arguments are the differences between an annuity and a non-annuity. So this time we used an annuity, therefore had the payment, as opposed to having two commas, not using the payment and having the future value. But so I can have another comma. It will then take us to the future value. We're not going to use the future value, but I might want to get over here to this, to the type argument. So comma again will take us to the type argument, which by default they have as a normal annuity. Now we could choose the number 1 here, and that would change it to basically an annuity due. So if we want it by default have that 0 up top, it won't change the bottom line number. It's just going to be the same thing. If I choose 1, then it will change the default settings. So if I keep that there, we're still at the normal kind of annuity, even though we extended kind of the formula to include the type explicitly. Now here, let's do that, and then we'll change the type to the beginning of the period. So same starting point, negative present value, shift 9. Rate is going to be the 5%, comma. Number of periods is now going to be 6, same thing, comma. Number, and then the payment is once again going to be 1,000. And then I'm going to try to get over that type field again. So I'm going to add another comma. And now the future value, we don't have a future value because it's an annuity calculation. So another comma. And now we have the type, which I'm going to choose beginning of the period, which is indicated by a 1. You could double click on it or type in a 1, and we get to a different result, which is going to be that 5,329 as opposed to the 5,076. Now, to kind of solidify this in our mind, we can do our running balance type of calculation starting at the end result and kind of working it back to see what is going on here. Sometimes it's a little bit easier with this particular calculation to kind of think about it, well, because if we have the $1,000 payments at the 5%, sometimes it's easier to actually project it out to the future value and then present value it back. Sometimes that clicks more in people's minds. So let's just see what that would look like. For example, if I thought about this as a future value calculation at the 5%, and then I brought it back to the current time period, we'll get to the same end result. So for example, I'm going to make this a future value annuity, the same series of payments, same rate, but now I'm going forward in time. We're going to end up at a point 6 years out, and then we're going to have to bring that point back to the present to get to the current present value. So for example, it would look like this: negative future value, shift 9. The rate would be the 5%, comma. Number of periods would be 6 periods, comma. And then the annuity, we're going to pick the 1,000, we have the same kind of thing. I could go to the type here and make it a 0, but it's already there by default if I leave it as is. So I'm going to say OK. That would then be the future value. So that would be this series of payments as if they were earning 5%, and that's where we would be 6 years in the future. Now I can say, okay, well, what if I took that future value 6 years out and I use a present value of 1, taking that single amount back to time period 0, discounting it at the 5%. That should give us to the same result that we got to up here. So let's try that. That's going to be negative present value, shift 9, rate 5%, comma, number of periods is going to be 6, comma, and then no payment because now we're going to use present value of 1 for that one number, comma, and then up once to that future value we just calculated and enter, and that'll give us to that 5,076. Now, sometimes the reason that's kind of easier to see sometimes is because when you do the running balance for an annuity, it's kind of easier to build the table going forward to get to the future value of that 6,802 to kind of verify it in your mind and then bring it back using the present value calculation here. Of course, you could do the same thing for like an annuity due. I can do annuity due, going forward into the future, which would look like this, negative future value, shift 9, the rate 5%, comma, number of periods would be 6, comma, the payment would be 1,000, comma, and then I'm going to try to get over that type field again. So I'm going to say comma again, bringing us to the type. And this time I'm going to choose the 1 to make it at the beginning of the period and enter. So now we're at the 7,142 if we were to visualize it going out 6 years into the future. And then if I simply present value that back to the current time period, 6 years back, we should get to this 5,329, which we could do by saying negative present value, shift 9, rate is going to be the 5%, comma, number of periods is going to be 6, comma, because this is not an annuity, future value would be that number we just got to, and then that would bring us back to the 5,329. So again, that could give you some idea and then you can kind of do your running balance tables to come up to these numbers, which could solidify, how this whole thing works. We're going to now try to recalculate, use these numbers to kind of verify what we have done. So let's go over here and think about our running balance for a normal kind of annuity. I'm going to start at 0, 1, 2, select those 3 numbers, autofill on down. We're going to go to the Home tab, the Alignment and Center, and I'm going to start at the balance, which is the end result here of our normal annuity, which was the 5,076, and then try to prove this by basically going through our series of payments and ending up at 0 at the end of this process. So in other words, we're going to say that the increase here would be equal to the 5,076 times the 5%. The payment is going to be that even 1,000 each time, 1,000 each time. And I'm just going to copy this down. So I'm going to double click on this one. That 5% is outside. So we're going to make it an absolute reference, selecting F4 on the keyboard, $ before the B and 2. This payment is outside. So I'm going to make it absolute by selecting F4 $ before the B and 1. And then I'm going to add this up. This is the prior balance, the 5,076, plus the sum of these two numbers. This one being a negative means that when I sum them together, which usually means adding, it means it's going to subtract it because I'm adding a negative number, closing the brackets. There we have it. So the 5,076 plus the 254 about minus the 1,000 brings us down to 4,329. Obviously, the increase that we're getting, the gain that we're getting is less than the payment that's going out. If we continue this process, we would assume then at the end of the 6 years, we would be down to 0 at that point. So let's select these 3, use our autofill by putting our cursor on the fill handle and dragging that on down, and we get to 0 at the bottom line number. So that should kind of verify, because you could say, okay, if I had a series of payments for $1,000, that's going to be equivalent to the 5,765 if the rate was 5% for 6 years, because if I was to take out $1,000 for each of that time period for the 6,000 over the 6 years at that 5% rate over that time period, I would end up with a net result of 0, even though I took out basically the 6,000 over the 6-year time period and started with an amount of only the 5,776 about. Now, if we did this one, it's a little bit more of a complex calculation here to do that. So I got a little bit more complex of a table. So we'll start here with 0, 1, 2. We're going to autofill that down, dragging on down, autofill that down to the bottom. We're going to go to the Home tab, Alignment, and center that. And we'll say that this balance then starts at the 5329. And then what we're going to say is the payment happens at the beginning of each year. So I'm going to say negative of the 1,000. I'm going to select F4 on the keyboard because I'm going to copy that down. So there's our negative 1,000. So the beginning balance at the beginning, January of year 1, we can say January 1st of year 1 would be that 5329 plus the 1,000, or in other words, plus a negative number or minus that number, bringing it down to 4,329, which will result in our increase being less because now we're saying it's happening from January to December, giving us an ending balance that we're assuming will be getting the interest on or whatever our gain is. So that's going to be the 4,329 plus, then we'll hold on a sec, 4,321 times the 5% up top. Once again, I'm going to select F4 on the keyboard to make that absolute. So there we have that. So now the interest is going to be less in year 1 here because we said that the payment happened in the front end. So then if we were to add this up, we would have an ending balance. This would be the ending balance, the sum of the beginning balance plus that increase. So now we're at the 4,546, and this is going to be, let's call it the ending balance. So then we can copy that down. If I was to copy this down and autofill that down, we then should get down to 0 at the bottom line once again. So we were at this point at the end of year 1, and then at the beginning, January 1st of year 2, we got the other 1,000 coming out. That means our beginning balance in January 1st of year 2 is the 4,546 minus the 1,000, or the 3,546. And then there's an increase on that for the year of year 2, January through December, which is that number times the percent of 5. And then we can add those two up. That's going to be then our ending balance, the beginning plus the increase. And then at the beginning of year 3, we're going to say that the $1,000 went out. So that means that at the beginning of year 3, we have this 3,723 minus the 1,000, or 2,723, which we're going to multiply times the 5%, and then add those two together to get the ending balance. And then at the beginning of year 4, we took out another 1,000. And so that means the beginning balance is that 29, or the 2,859 minus the 1,000 times the 5%, was it? 5% is going to give us 93. Ending balance is the adding of those two. And then at the beginning of year 5, we took out another 1,000. And that means our balance went down to 952 at the beginning of the year. We earned 45 during the year. And then if we add those two together, we got the 1,000 left. And at the beginning of year 6, we take that out, and that means we're down to 0, and we're not going to get any benefit in the year 6 because, of course, the balance is now down, and we're not going to get any income in on it.